So I want to give an example where we're using integration by parts, and we kind of have two functions here that oscillate. E to the theta stays e to the theta, and sine theta oscillates between cosine and negative sine theta, and goes back to cosine. I just wanted to show you, or help you gain a little bit of intuition on how to solve a problem like this. So first off, I'm going to assign, since we have f of x, g prime of x, I'm going to assign that in blue, assign f of x equal to e theta, okay, f prime of x is equal to e theta again, because when we take the derivative of e to theta, it's going to be e to the theta. And we're going to get g of x, or it's all in relation to theta, my apologies. But just know that this is theta, function with respect to theta. Okay, sorry about that. So g theta and g prime theta, not quite x. Alright, so g prime we're going to set to sine of theta, and the integral, if we integrate sine of theta, we're going to get negative cosine theta. Okay, and by doing this, we can rewrite our function as f of theta times g of theta, which gives us e theta times g theta, which is negative cosine theta, negative cosine theta. Sorry about this. Alright, and then we get, subtract the integral from g f prime of theta, which is still e theta, times g theta. So this is going to turn into a positive, so plus cosine theta. Alright, and then, since we need to integrate this again, we go down to start assigning f prime of, or f of theta again, f prime of theta. Okay, so f of theta is going to be equal to e theta. F prime of theta is going to be equal to the derivative of this, which is just e theta again. Okay, and we're going to have g of theta again, g prime of theta. G prime of theta is going to be cosine theta. Then we integrate, we get sine of theta. Okay. And now, as you see, we are going to have an oscillating function, because e theta is always going to remain e theta when you take the derivative or integrate it, and sine of theta will oscillate, between negative cosine, and positive sine, which will give us our new function again. I'm going to rewrite everything, so I'm going to have negative e theta times cosine theta plus this integral right here, which is going to give me e theta plus e theta times sine theta times sine theta times sine of theta, okay, minus the integral of e theta sine theta, minus the integral of e theta sine theta. Now notice, this right here is equal to our original equation. Excuse my notation because I forgot to write d theta to all these, because remember we're going to have that infinitesimally small number that technically doesn't change. It's just a very small number. Alright, so we have this exact same function up here. We have the exact same integral down here. So what I'm going to do is I'm going to set this equal to this. Okay, and then you'll see what I'm doing in a second. So I'm going to get our original integral. I'm going to move. Alright. Try and move the screen. So we're going to get the integral of e to theta. I'd like to do that in colors so you guys can see. E theta times the sine of theta d theta is equal to all of this over here. Get negative e theta cosine theta plus e theta sine theta sine of sine of theta minus e theta sine theta again. Sine theta d theta. Okay. So I'm going to add this whole piece to this side over here, and this d theta sine theta d theta sine theta d theta. Cancel that out, so I'm going to add it over here too. D theta sine of theta d theta will give me 2 times the integral of e theta sine theta d theta, which is equal to all this, negative e theta cosine theta plus e theta sine theta. Alright, divide everything by 2, both sides. Okay. Divide everything by 2. Now I'm going to get the integral of e theta sine theta d theta is equal to negative 1/2 e theta cosine theta e theta cosine theta, okay, plus 1/2 e theta sine theta. And here is your answer.